Welcome to our session today, where we will explore the powerful combination of Linux and Apache. We will discover how these technologies work together, truly powering much of the digital world. Let us begin by understanding the foundational concepts of Linux operating systems, a crucial topic in modern computing environments. We will explore the Linux kernel, which is the core component that powers almost everything we use today. Here, we focus on the Linux kernel itself, which is the heart of the operating system. The Linux kernel is an open source, Unix-like operating system kernel, freely available for everyone to use. It is versatile, powering a vast array of devices, including servers, supercomputers, desktops, and mobile devices. This powerful kernel was originally developed by Linus Torvalds back in 1991, marking a significant milestone. Now, let us consider some of the key characteristics that define the Linux operating system. First, it is open source, meaning its code is freely available for viewing, modification, and distribution by anyone. Linux is also multi-user, allowing multiple individuals to effectively work on the same system simultaneously. Furthermore, it is highly secure, offering robust features such as comprehensive permissions and built-in firewalls for protection. Its customizability is exceptional, enabling users to tailor almost every aspect of the operating system to their specific needs. Let us now examine the core strengths of Linux, focusing on its stability, security, and adaptability. Linux is highly stable, secure, and adaptable, making it a versatile choice for many applications. Being open source means its source code is freely accessible, allowing anyone to view, modify, and distribute it. This fosters transparency and continuous improvement within the global developer community. Linux excels in multi-user multitasking, supporting many users and tasks simultaneously without performance degradation. This capability is crucial for servers and enterprise environments. Linux is highly secure, providing robust features such as advanced permissions and built-in firewalls. These security layers protect your system from unauthorized access and potential threats. Its customizability is a major advantage, as users can tailor almost every aspect, including the kernel itself. This flexibility allows for specialized configurations to meet unique system requirements. Now, let us explore some of the common Linux distributions that are available for various purposes and users. These distributions offer different versions of Linux, catering to every specific need and type of user. First, we have Ubuntu, a very popular and user-friendly distribution. Ubuntu is particularly well suited for beginners due to its intuitive interface and ease of use. It is also widely popular for desktop environments, providing a smooth and efficient user experience. Next, we look at CentOS, which is known for its stability and reliability. CentOS is considered an enterprise-grade operating system, offering a stable and robust platform. This distribution is often utilized for server deployments, providing a dependable foundation for web services. Then there is Debian, another highly respected and influential Linux distribution. Debian is widely known for its exceptional stability, making it a reliable choice for various applications. It also boasts a very large software repository, offering a vast collection of packages and applications. Finally, we have RHEL, which stands for Red Hat Enterprise Linux. RHEL is a commercial enterprise operating system, backed by professional support and services. It is specifically designed and optimized for businesses, providing a secure and scalable solution for corporate environments. Let us now understand the hierarchical Linux directory structure, which organizes files from the root. This structure ensures efficient management and access to all system files and directories. The / represents the root directory, which is the starting point of the entire file system hierarchy. All other directories and files branch out from this central root. The / home directory contains user-specific files and their personal settings. Each user typically has a subdirectory within / home for their data. The / etc. directory holds configuration files for the system and various applications. These files control how the operating system and installed software behave. The / var directory stores variable data, such as system logs, cache files, and spool files. This data often changes during normal system operation. The / bin directory contains essential binary executables for common system commands. These are fundamental commands required for basic system operation and maintenance. Now, let us cover some essential command line interface commands in Linux. These commands are crucial for navigating and effectively managing your system. First, let us look at commands for listing files and directories within a given path. The ls command displays the contents of a directory, which is fundamental for navigation. To list files with detailed information, you would type ls space -l. Next, we will learn about the command used for changing directories within the file system. The cd command changes your current working directory and requires a path as an argument. For example, typing cd space /var/log will move you to that directory. Finally, we have a command for printing the current directory you are in. The pwd command prints the absolute path of your current working directory. Just type pwd to quickly see your exact location in the file system. Today, we will begin our introduction to the Apache HTTP server, a fundamental component of web infrastructure. Apache is a widely used web server software, playing a critical role in delivering web content globally. Here, we are focusing on the Apache server, which handles requests from web browsers. It is an open source web server software, freely available and widely adopted across the internet. This powerful server was developed and maintained by the Apache Software Foundation, a global community. Apache is primarily used to host dynamic websites and complex web applications, serving content to users. Now, let us delve into some of the key features that make Apache a preferred choice. Apache offers excellent cross-platform compatibility, working seamlessly across Linux, Windows, and Mac OS. Its modularity allows for extensive customization to various modules, adding specific functionalities as needed. The server's flexibility means it is highly configurable for diverse use cases, from simple sites to complex platforms. For security, Apache provides robust SSL/TLS support and comprehensive access controls to protect your data. Let us now discuss how to manage the Apache web server on a Linux system. This includes installation procedures and controlling its service. To begin, you will update your package list and then proceed to install Apache 2. We first run sudo apt update and then sudo apt install Apache 2. To activate the web server, you need to start the Apache service. This is done by executing the command sudo system ctl start Apache 2. If you need to temporarily take the server offline, you can stop the Apache service. You would use the command sudo system ctl stop Apache 2 for this action. To apply configuration changes or resolve minor issues, you can restart the Apache service. Simply type sudo system ctl restart Apache 2 to perform a graceful restart. We will now learn how to set up an Apache virtual host, which is essential. This allows you to host multiple websites on a single server, maximizing resource usage. First, create the document root directory for your new website and assign proper ownership. We use sudo make directory -p/var/www/example.com, then change ownership. Next, add some sample HTML content to your newly created website. Use the echo command to put an h1 tag with welcome to example.com into index.html. Now, you need to create a dedicated virtual host configuration file for your website. This is typically done using sudo nano /etc//apache 2/sites available /example.com. Finally, enable your virtual host and then reload the Apache web server to apply changes. Execute sudo a2nsiteexample.com.conf, then sudo system ctl reload Apache 2. We will now cover troubleshooting the Apache web server, focusing on diagnosing and resolving common errors. Understanding these issues will help you maintain a healthy and functional web server. A 404 not found error indicates that the requested page or resource does not exist. Check the document root path and ensure the file is present in your Apache configuration. A 403 forbidden error means you lack the necessary permissions to access a resource. verify directory and file permissions, or examine any .htaccess rules that might be blocking access. A 500 internal server error usually points to a problem with the server's configuration or script. Inspect the Apache error log file for specific details and clues to the underlying issue. If you experience a slow server response, it suggests a performance issue or high load. Analyze server load using the top or htop commands to identify resource bottlenecks. Let us conclude with a summary, highlighting the key takeaways to remember from our session. These points encapsulate the most important concepts we have covered today. Linux is a powerful, open-source operating system that is essential for servers and development environments. The Apache HTTP server is a robust, widely used web server for hosting dynamic websites. Virtual hosts are crucial, enabling the efficient hosting of multiple distinct websites on a single server. Effective log management and thorough debugging practices are vital for maintaining server health and performance. Implementing proper permissions and strong security measures is paramount for web server stability and protection.